gyre. This is the study area. And you can see how the ocean moves in this direction. Yeah? And then normally the vessels don't take this route because the wind is so calm, and then they need to use more oil, yes, more fuel. And then here in this area is very characteristic because it has a high pressure and the current in the ocean is clockwise. And this is very funny because it's like the spiral is in war in the very deep in the center, and this is why all the plastic debris is stuck in this area. It's trapped from different sources, and this area we can say it is like a 2 times Texas state. The size is huge. And then here, the center, the North Pacific Gyre, is called to the eastern garbage patch. You find a lot of garbage. And this is the type, the samples in this area. And how made the identification of the type of plastic that I found? I used the Fourier transform infrared spectrophotometry. And I used the virgin pellet as a standard. We're working now in the lab and we are using this virgin pellet, but we are working just with the density properties. This is the result. You can see this is my standard in polyethylene from the virgin pellet, and this is one sample. And you can see how it's very similar. And this is the standard for the polypropylene, and this is one sample. In total, I can say the polypropylene I found in 22% of the samples, and polyethylene 70%. This means polyethylene is the main compound that I found in the ocean in this time. Now, how I made the analysis? First, I'm taking the samples and I use the stethoscope to pick it up, the plastic from the water. Later, I made the source lead extraction. In this thimble, I put in the sample and the extraction was 24 hours. I concentrate the sample in 1 milliliter, and I use the liquid chromatography for cleaning the sample, and concentrate again in 1 milliliter and use the gas chromatography mass spectrometry to make the identification and quantification of each compound. This is one example. This is from the gas chromatography. This is one sample, and I found 35 PCBs. And this is the family from 209 compounds. And I can make the identification in each compound using the mass chromatography, because each compound has a special signal. It's like a fingerprint for each compound. And I can make the quantification using just one peak. We call it this technique, the select ion monitoring, because we can quantify very, very low concentration of these compounds. And this is the result in the PCBs. You can see is the range is huge because we don't know what is the source. And this is the main PCBs that I found. 51% of the total of the sample, we can say the nearly 28 nanograms by gram of PCBs. And this is for the pesticides. And here, the main compounds that I found was the DDTs, and it's metabolized. This is DDD and DDE. And DDE is the most stable compound and can stay more than 40 years in the sediment. And 40% of the total samples, the mean was the 45 nanograms by gram, the sample. And in polyaromatic, we see there is huge the range, because the main source for this is atmospheric. When I stay here in the North Pacific Gyre, I can smell when the vessel, the huge vessel, cross to the yard, I can smell the fuel. You know, because in the international waters, they can burn whatever. And then they produce a lot of pollution. This is the catamaran. I went in September 9, 2007, 6 p.m., say Baja. And we went to Hawaii. This is the different type of samples that I found. Look at this. This is the balloon, Happy Birthday balloons. We found several ghost net and this tire and different kind of plastic, a lot of different kind. And this ghost net, the idea, we just mark with this GPS. This is one huge buoy because we put this in this ghost net because it's so heavy and we cannot carry it in the catamaran. And we found 3. And then we put this and then no one can track in the buoy. I can find it and pick it up. And they use it with the satellite for follow the movements, and we can try to see if we have a patterns in how the garbage is moving in the non-Pacific jar. And this is how we take the sample, the whole plastic. But you know, the catamaran is small. If we try to do this in the Guardian, forget it, we can't. This is so huge. And sometimes we have this type of plastic too, and you can see how many organisms we have here. This means this plastic stayed there, I don't know how many years, more than 10 easily. And then in this plastic we found a lot of organisms. Always we find plastic and organisms. And with this is the manta trawl. We collected we filtered the water and we can collect this type of samples. And for the first time, I filtered the seawater, and that I found in the filter, you can see the filter and you don't see nothing. And then when I use the microscope, I can see plastic. Different sizes, colors of plastic. And this was using just the dissection microscope. Okay, it's plastic. And the people say the Eastern garbage patch is like a desert in the ocean. But it's not true, because it's a lot of life. You can see this, you know, it's a lot of organisms that are eating the plastic, the human rubbish, because they don't know. And that I can say in my result is the plastic behave as sediment, like a sediment. What does mean this? I told you that the sediment are the last reservoir for all the pollutants that are in the floor. But now we have in the ocean, and these are floating. And then the conclusion is the plastic are fragmented and degrade in the new class of sediments. We can say now we have a new class of sediment floating in the ocean. And the ocean, okay, first let me talk about this. This is one model from Dr. Ingraham in the NOAA. He studied, for example, this plastic, polyethylene terephthalate. In 1996, in the United States, the production was 1 million tons. But this increased in 2.5 million tons in 2005. We're producing a lot of plastic. And with this model, the idea is to see what is the plastic that is produced in Canada and the United States, and the red is from Japan. Because now Japan is one of the main producers of plastic too. And this is after 183 days. How? Remember, the water is moving in these directions. And here is after 3 years, and here is 10 years. What is that you notice? What you can see with this model. Here is my study area, North Pacific Gyre. Then we can see the red reach very fast this zone, yeah? And it's true, we find a lot of plastic, red plastic. We put it in red, I don't know, but the ocean in China, they use the red because it's the good luck, yes? And then we find a lot of red plastic. And this is the first that the organisms eat it. Why? Because they confuse with the squid. They confuse and they eat it. And you can see how here in the North Pacific Gyre is mainly is the plastic from Japan. And then take another 10 years to all this plastic